Hello everyone and welcome to Exponents and Radicals lesson number 3. So now we are going to look at entire radicals and mixed radicals. So just a little review from lesson 2. We know that the square root of a times the square root of b is equal to the square root of a times b. And when you divide the square root of a divided by the square root of b, it's like the same as doing the square root of a divided by b. And also we can look at those in reverse, right? We can split the square root of ab into the square root of a times the square root of b, and we can split the square root of a divided by b into the square root of a divided by the square root of b. So it says here, write the following as a product or a quotient of radicals. So they started here with the square root of 24, and we know 4 times 6 is 24. It's just, oh, it's not letting me scroll now. Good. So we know 4 times 6 is 24, so we can write that as the root of 4 times 6, or the root of 4 times 6. Square root of 18, we know 18 is 9 times 2, so it can be written as the square root of 9 times 2, and then we can split that into the square root of 9 multiplied by the square root of 2. Oh wait, you can actually take these a step further. Let's go back to the first one. So we were left with square root of 4 times square root of 6, but we know that the square root of 4 is actually just equal to 2. So we can write that as 2 multiplied by the root of 6. Same with the next one. We have square root of 9 times the square root of 2. The square root of 9 that's a perfect square. So we know that that is going to be 3 root 2. And then the next one, we have the square root of 11 over 4, which is the same as the square root of 11 over the square root of 4. And we know that the square root of 11 isn't a perfect square, so we'll leave it, but the square root of 4 is 2. So that is like saying where it can be simplified into the square root of 11 divided by 2. So it says here, use a calculator to approximate the value of each of the 5 radicals. So the square root of 80, if we type that into our calculator, comes out to be 8.94427. The next one is 2 multiplied by the square root of 20. So if we did that in our calculator, we'd get 8.94427. And the next one is 4 multiplied by the square root of 5. And if we did that in our calculator, we'd get 8.94427. What do you notice about the answers? They are equal or the same. So it says complete the following to explain why all 3 of those radicals are equivalent. Well, we can split the square root of 80 into the square root of 4 times 20, which can be written as the square root of, hang on, sometimes I don't know how I do that. Let's scroll up a little bit. So the square root of 80 can be written as the square root of 4 times 20, or the square root of 4 times the square root of 20. And we know 4 is a perfect square, so we can write that as 2 root 20. You can also split 80 into 16 times 5. And we know 16 is also a perfect square. So the root of 16 multiplied by the root of 5. The root of 16 is just 4 multiplied by 5. So basically, the square root of 80 is equal to 2 root 20, which is also equal to 4 root 5. So the square root of 80 is an example of an entire radical. The number is entirely under the root symbol. But the other two, the 2 root 20 and 4 root 5, are examples of mixed radicals because they have the number out front multiplying, or the coefficient. So there's a couple of good examples here. Entire or pure radicals are radicals expressed in the form where the entire root is under the entire number is under the root. And they've got 3 examples right here. And mixed radicals are in the form of a root b, where we have a number out front being multiplied. So the examples are 2/3 multiplied by root 5, 8 multiplied by root 7, and -9 multiplied by cube root 17. Every mixed radical can be expressed as an entire radical. So I'll show you how we do that. So here's a great example. We have root 108. That's an entire radical. We want to write it as a mixed radical. So basically we're trying to find two numbers that multiply to 108 because we want to split that. But one of those numbers we want to be, because this is a square root, right? There's a 2 there. We just don't see it. We want one of those numbers. I'll write that here. 108. We want one of the numbers multiplying to make 108 to come from the perfect squares list. So I think in this case we have 3 times 36 to get 108. 36 is right here on our chart. So these get a little bit tricky. That's why it's good to memorize the perfect squares and the perfect cubes list, because it'll make these a little bit faster. So now we can write this as the root of 36 times the square root of 3, and then we know the square root of 36 can just be written as 6 times root 3. So then we know that the entire radical, the square root of 108, can be written as 6 root 3 as a mixed radical. So this is the entire radical, and this is the mixed. So if there's a couple of these numbers that end up working over here, and you don't choose the biggest one, then you end up just having to do another step. You'll be able to factor more out of that root there. But if you can find the biggest one, so in this case 36 was the biggest one, or the largest perfect square that worked there, then you're done. You're good to go. So it can be a bit tricky, but the more comfortable you are with the perfect squares, the easier it'll be. So you can see that we have a square root of 50 here. We know that 25 times 2 is 50, and 25 is a perfect square. So the square root of 25 times 2, or the square root of 25 times the square root of 2, and the square root of 25 is just 5. So there's your answer, 5 root 2. 45. Well, we know 9 times 5 is 45, and 9 is the perfect square here. Sorry, I just had a little bit of a brain fart. I was thinking about something else. So we can write this as the root of 9 times 5, or the root of 9 times the root of 5. And then we know the square root of 9 is just 3. So now we have 3 root 5. When they get into larger numbers, they do get a little bit tricky. A good strategy would be to look at these numbers and say, okay, 320 divide by 81. Do you get a whole number? 320 divide by 64. Do you get a whole number? And with 64 you do. It's 64 times 5. So you can say 320. Oh, not 320. Sorry. The root of 320, or the square root of 320. My eraser's not working. That's fun. All right, scribbling it out. Can be written as 64 multiplied by 5. Or we can separate that into the square root of 64 times the square root of 5. And we know the square root of 64 is 8. So we get 8 root 5 in simplest terms. Let's go through a couple more examples. So convert the following radicals to mixed radicals in simplest form. So we already have a 2 out front, so this is a mixed radical, but we want to make the root as simple as possible. So with 192, again, these are going to take a little while longer. I'm just going through the example pretty quick, but you do have to develop a good process, and it's good to memorize those square root and cube root charts. So you can rewrite this as 2 root 64 times 3, because 64 times 3 is 192, or 2 times root 64 times root 3. And then the root of 64 is just going to be 8 times root 3. And then to simplify this, you can say, well, 2 times 8 is just 16 root 3. And there's your final answer right there. Same with 3/4 multiplied by the square root of 160. So we do 3/4, and then we can split 160 into square root of 16 times the square root of 10. And then we have 3/4 times 4 multiplied by root 10. And then 3/4 times 4, hopefully your multiplying fractions is okay. 3 times 4 is 12. 4 times 1 is 4. 12 over 4 is 3. So we get 3 root 10. Another way to think about that, if you want, is that if you have a 4 on the top and a 4 on the bottom, they end up canceling each other out, right? 4 over 4 is 1, and you're left with 3 over 1, but that's just 3. It's a pretty quick way to look at it. You could say, well, 3/4 multiplied by 4, 4's cancel, 1 on top of the other, and so then you're just left with 3 root 10. And then the last one here, we have, you can break that into the square root of 7 over the square root of 9, and then we know that 9 is a perfect square, so you can write it as the square root of 7 over 3, or you can write it as 1/3 root 7. That's the same thing, right? If you divide by 3 or multiply by 1/3, that's the same thing. So whatever way you want to write that. So we're going to do the same thing, but with cube roots, and that gets a little bit trickier. People are less familiar with this list here, but it's the same process, but with perfect cubes. So the example they have here is the cube root of 54. So 54 can be written as 27 times 2, and 27 is one of our perfect cubes. So then we can say that it's the same as the cube root of 20. Come on now. The cube root of 27 times the cube root of 2. And then the cube root of 27 can just be written as 3, because we know that the cube root of 27 is 3, or 3 cubed is 27. And so now you can say that the cube root of 54 is the same as 3 cube root 2. It's a harder process. It is good to be able to do, but it does take a little bit more time. Convert the following radicals to mixed radicals in simplest form. I'm going to go over A and C, and I'll leave B as a challenge question for you. It is tricky, and I'm probably not going to ask you how to solve fifth root questions, but it is a good challenge question for those of you who are maybe finding the material a little bit too simple or a little too slow. Make sure you can do that. So the cube root of 6,000 can be written as the cube root of 6 times 1,000, or the cube root of 6 times the cube root of 1,000. And we know the cube root of 1,000 is just 10. So we have cube root 6. That's not right. The cube root of 6 multiplied by the cube root of 1,000 is just 10. So I just got them in the wrong order here. 10 cube root 6 is your final answer. And then the last one here, the cube root of -16. So if you scroll up and check your cube root list here, it looks like 8 times 2 is 16. So what you could do is, you're allowed to take the cube root of negative numbers, right? You remember that? So you can split this into the cube root of -8 multiplied by the cube root of 2. So if you know you're going to switch the 8 part of that factor into a coefficient or just a whole number, take the negative with it if you're doing cube roots. You're allowed to do this. So we know the cube root of 8 is the same as -2, and that way you have the cube root of a positive number in the end. I'll just write that a little bit nicer. So your answer has the negative out front and not the negative in the inside the cube root. Makes it look a little nicer. Cool, that's it. Thanks for watching. Hopefully that wasn't too painful, and hopefully you're starting to understand mixed radicals and entire radicals. Thanks for watching.